Hello everyone. Before starting the lesson, try this warm-up. For a sphere, the area as a function of the radius is 4 pi r squared, and the volume as a function of the radius is 4/3 pi r cubed. Simplify the surface area to volume ratio. That's the ratio of this to this, which would be this ratio, surface area to volume. So pause the video, see if you can simplify this expression as much as possible. I notice that I have pi in the numerator and denominator. Pi divided by pi is 1, so that cancels out. R squared divided by r cubed. Well, remember when you're dividing powers with the same base, r, subtract the exponents. 2 minus 3 is minus 1, or I'm just dividing by r. So I got this 4 divided by 4/3 r. So this looks weird. I'm dividing by a fraction. You remember how to divide by a fraction, you multiply by the reciprocal. So 4 divided by 4/3 is the same as 4 times 3/4. 4 times 3/4 is just 3. So here I have 3 over r as the simplified expression. And that's really what this lesson is about. It's about simplifying expressions with exponents. We're going to be simplifying algebraic expressions involving powers and radicals. So we're going to use what you've learned from the past few lessons and simplify more complex expressions in this lesson. So this is the first of 4 examples that I'm going to walk you through in this lesson. For all of them, we have to look at our exponent rules and rules for radicals that we looked at in previous lessons and how we can simplify at each step along the way. I see this fraction, and I can't simplify the x's right off the bat because look at this. I have a power with this expression as its base. So I'm going to simplify the numerator first, then I'm going to simplify the denominator separately, and then I can start simplifying the fraction. So if I look at the numerator first, this exponent of 3 applies to the entire thing in the brackets. So the 2, the x to the minus 3, and the y to the 2 all have an exponent of 3. So basically, we're going to use our power of a power rule. We have pretty much 3 different powers in this base, all multiplied together. We're going to have 2 to the exponent 3, x to the minus 3 to the exponent 3, and y squared to the exponent 3, like this. Now I can simplify this. I can figure out what 2 to the exponent 3 is. It's just 2 times 2 times 2. I can figure out what this is. It's a power of a power, so I multiply the exponents. This is also a power of a power, so I can multiply the exponents. So my numerator ends up being 8, x to the minus 9, y to the 6. Now let's do the same thing with the denominator. I use my power of a power rule, so I multiply the exponents, and I end up with x to the 6 times y to the minus 8. So now I've simplified the numerator, I've simplified the denominator, now I can start simplifying the fraction. Well, I have 8 and no corresponding number down here. That means there's a 1, so 8 divided by 1 is 8. Then I have x to the minus 9 divided by x to the 6. Well, if I'm dividing powers with the same base, I subtract the exponents. Do the same thing with these powers with a base of y. So just remember, it's x to the minus 9 minus 6, which is minus 15. Here, it's 6, and I'm subtracting minus 8. So it's that double minus 6 plus 8, that's 14. So I've got 8 times x to the minus 15 times y to the 14. Now, I don't like negative exponents, So just remember how to deal with negative exponents. You can turn that power into a power of the reciprocal with a positive exponent. So here I'm multiplying by x to the minus 15. The reciprocal of that would be dividing by x to the positive 15. So I can turn this expression into this. It's saying the same thing, but I don't have any negative exponents. And this would be the simplified form. So look at all we did. We took this complex looking expression and we simplified it down to this less intimidating version. But all we did was use our exponent rules. Power of a power, and then dividing powers with the same base. In this next example, we're going to simplify it in a similar way. It's just that our exponents are expressions themselves. But here we're multiplying powers with the same base, and then we will be dividing by powers with the same base. So think about your exponent rules. If you're multiplying powers with the same base, you add the exponents together. So here I'm adding the exponents together. When I do that, I end up with 5n as the exponent on x in the numerator. Now I'm dividing powers with the same base, so I will subtract the exponents. So 5n minus 2n minus 5. 5n minus 2n is 3n, and then we're subtracting minus 5, that's plus 5. So I can take this complicated looking expression and simplify it down to this, x to the exponent 3n plus 5. But again, I'm just following my exponent laws, multiplying and dividing powers with the same base. Now this one, we're going to simplify again. We have power of a power, and we're going to be dividing powers with the same base. So we're following the same process as before, it's just that we have a rational exponent, which means it's a fraction. And people get thrown off by fractions. That's the only part that makes this tricky, is if you have trouble with fractions. But let's look at the numerator. 27 to the exponent 1/3, a to the minus 3 to the exponent 1/3, and b to the 12 to the exponent 1/3. And remember, if you have a power of a power, you just multiply the exponents together. So on the power with a base of a, the exponent would be minus 3 times 1/3. For b, it would be 12 times 1/3. Now 27 to the exponent 1/3, remember that's a rational exponent. That's the cubed root of 27. That's 3, because 3 times 3 times 3 is 27. So we know what the cubed root of 27 is. Let's simplify it. Multiply negative 3 times 1/3. 1/3 of negative 3 is negative 1. And 12 times 1/3 is 1/3 of 12, which is 4. So this gets simplified to 3 times a to the minus 1 times b to the 4. Do a similar thing with the denominator, and you end up with 4 times a to the negative 4 times b to the 6. Of course, the exponent of 1/2 is the square root. So this is the square root of 16. That's where the 4 came from. Negative 8 times 1/2 is negative 4. 12 times 1/2 is 6. That's where those came from. So now I don't have a power of a power anymore. I'm going to use my rules for dividing powers with the same base. So 3 divided by 4 is 3/4. A to the minus 1 divided by a to the minus 4 is, well, subtract the exponents. A to the minus 1 minus minus 4, which is 3. B to the 4 divided by b to the 6 is b to the 4 minus 6, which is minus 2. Now this, I don't like negative exponents. Plus I have a fraction here. Let's all put it together into one fraction. I have 3 times a to the 3. I'm dividing by 4, b squared. Because remember, b to the minus 2 can be written as 1/b to the 2. So I can combine all those ideas, and I get 3a to the 3 divided by 4b squared as my simplified expression. So again, I have power of a power rules, and I have dividing by powers with the same base rule, and I have my negative exponent rule that I'm using as well. Nothing really new in this lesson. We're just combining ideas from previous lessons. Now, my last example involves radicals. So just remember how you can rewrite radicals as rational exponents. The fifth root of x to the 8 is x to the 8 over 5. The square root of x to the 3 is x to the 3 over 2. So I've just rewritten my radicals as powers with rational exponents. Now, this exponent of 3 applies to the numerator and the denominator, power of a power rule, so multiply your exponents. So 8 fifths times 3 is 24 fifths. 3 over 2 times 3 is 9 over 2. Now I'm dividing powers with the same base, so I will subtract my exponents. And this is where you might have trouble. 24 over 5 minus 9 over 2. When we're adding or subtracting fractions, we have to have a common denominator. So if I look at 5 and 2, the common denominator I would make is 10. I need 2 of these to make 10, so 2 of these will make 48. To turn this into a 10, I multiply by 5, so I'll multiply the numerator by 5 as well. So 24 fifths minus 9 over 2 is 48 tenths minus 45 tenths, which is 3 tenths. Now, the question asked me to simplify this expression, and I've simplified it down to a single power. Now, you could keep going. I could turn this back into a radical because it's a rational exponent. So the denominator of the exponent tells you what kind of root it is, and the numerator tells you what exponent you're raising that to. So this is the 10th root of x to the exponent 3 in radical form. Now, if you had stopped here, that would still be fine. This is a simplified form. But I'm just showing you could also write it as the radical form, and that would be equally as correct. So as far as the math goes, there's nothing really new in this lesson. It's just that we're combining these exponent laws and the idea of rational exponents in with these power of a power, multiplying powers with the same base and dividing powers with the same base in order to simplify an expression. Your expressions might involve multiple powers, but remember, these rules only apply to powers with the same base. So as you're practicing and you're running into issues, just reach out and I'll do my best to help.